Hello students, in this class we are going to discuss about a Hofmann rearrangement. This Hofmann rearrangement can also be called as Hofmann bromamide degradation, Hofmann bromamide degradation reaction. Okay, this Hofmann rearrangement is also called as Hofmann bromamide degradation reaction. See, when a primary amide is treated with bromine in an aqueous or ethanolic solution of sodium hydroxide, it gives a primary amine. Which has one carbon less than the parent or original amide. This reaction is called as Hofmann rearrangement, or we can write Hofmann bromamide degradation reaction. Hofmann bromamide degradation reaction. See, when a primary amide, we know the formula for amides. This is a primary amide, that is 1 degree amide. When it is treated with a bromine in an aqueous or ethanolic solution of sodium hydroxide. In place of this sodium hydroxide, we can use potassium hydroxide also. Okay, when an aqueous or ethanolic solution of sodium hydroxide, we will get what? It gives a primary amine which is having the formula RNH2. This is primary amine, and also they are telling this primary amine which we are getting is having one carbon atom less than the parent or the original amide. See, in this amide, here one carbon is there, that carbon is missing here. Therefore, they are telling the product, that is the primary amine which we are getting, is having one carbon atom less than the parent amide. And along with this one, we are getting Na2CO3, sodium carbonate, and 2 moles of sodium bromide and 2 moles of water. Okay, and to balance this one, here we have tried 4 moles of sodium hydroxide. See, when the primary amides are treated with bromine in presence of aqueous or alcoholic solution of sodium hydroxide or potassium hydroxide, that amide is converting into a corresponding primary amine which is having one carbon atom less than the parent amide. And along with this one, here we are getting sodium carbonate, sodium bromide as byproducts along with the liberation of 2 moles of water. And this reaction is called what? Hofmann bromamide degradation reaction. Okay, and we can see some examples for this one. CH3CONH2. This is acetamide. it is a primary amide, and when it is treated with bromine in presence of 4 moles of sodium hydroxide, we will get CH3NH2. See, this CO will go, and here CH3NH2 we will get. This is a primary amine, methyl amine, and along with this one we are getting Na2CO3 plus 2 moles of sodium bromide plus 2 moles of water. Okay, and we can write for aromatic primary amide, CONH2. This is benzamide. Benzamide, when it is treated with bromine in presence of 4 moles of potassium hydroxide, in place of NaOH we can use potassium hydroxide also, KOH. Okay, and here we will get NH2, aniline, and K2CO3, so K2CO3 plus 2 moles of KBr plus 2 moles of water. Okay, these two are the examples for Hofmann rearrangement or Hofmann bromamide degradation reaction. And coming to the mechanism, we can discuss the mechanism also here. The mechanism of this Hofmann bromamide degradation reaction involves the following steps. Step number 1 is what? First, the base abstracts a proton from amide. First, the base will abstract a proton from amide to form amide anion. And this amide anion then reacts with bromine to form N-bromamide. See, we have RC double bond O, N, H, H. Okay, and here this nitrogen is having lone pair of electrons. And what they are telling in first step, base abstracts a proton from amide. Here 2 hydrogens are there, and the OH minus from the base will now abstract one of the hydrogen as H plus, and this bonded electron between the nitrogen and hydrogen will now move towards nitrogen. And here, after a loss of a molecule of water, we are getting R C double bond O N H. Okay, and here it is having only 2 bonds with 2 lone pairs of electrons, and therefore it is getting negative charge, that is called amide anion. First, the base will abstract a proton from the amide to form amide anion. This is amide anion, and this amide anion will now react with bromine. And it will abstract one of the bromine atom, and these bonded pairs of electrons will now move with this bromine, and here we will get minus Br minus. Bromide ion will go here. Okay, and it results in the formation of RC double bond O NH, lone pair of electron, and it is Br. It is called what? N-bromamide. This is first step. And in second step, what happens? Again the base abstracts a proton from this N bromamide. Again the base will abstract a proton from this N bromamide, and on 1,2 migration, that is 1,2 migration of an alkyl group, 1,2 migration of an alkyl group gives isocyanate intermediate. It will give isocyanate intermediate. See, this is our N bromamide, R C double bond O N. Here I will write now H, and here I will write Br. Okay, here the OH minus from the base will abstract this hydrogen, and these bonded pairs of electrons will now move towards nitrogen, and here a loss of water molecule takes place, and here we will get R C double bond O N Br, and here two lone pairs of electrons with a negative charge. Okay, then now here what they are telling, 1,2 migration of an alkyl group takes place. This alkyl group will now takes place from position number 1 to 2. 1,2 migration of this alkyl group along with the bonded pair of electron, and as here this carbon, after the loss or the breakage of this bond, this carbon is now having only 3 bonds, 1 2 3, and to satisfy that covalency of carbon, this extra pair of an electron which is present on the nitrogen is now moving towards this carbon nitrogen single bond, and as here the nitrogen is forming 4th bond, already 1 2 are there, here another is forming, and here one more is forming, and therefore to get stability it will leave this Br as a Br minus. Now another bromide ion is going out from the reaction as Br minus, and here we will get R, I will write from this side, R N double bond C double bond O. Correct? This is called what? Alkyl isocyanate. Alkyl isocyanate. This is step number 2. And in step number 3 of the mechanism, hydrolysis of alkyl isocyanate takes place, which is followed by the decarboxylation, gives amine. See, the third step involves what? Hydrolysis of alkyl isocyanate. This alkyl isocyanate R N double bond C double bond O will now undergo hydrolysis. See here, O H H. This one of the double bond, that is the pi bonded electrons between this nitrogen and carbon, will now abstract one of the proton from water. Okay, and these bonded pairs of electrons will now move towards oxygen, and as the oxygen is getting an extra pair of an electron with a negative charge, it will donate one of the lone pair of electrons to the carbon. Okay, here this nitrogen is bonding towards hydrogen, and this oxygen is forming a bond with carbon, and here we will get R N H with a lone pair of electron, C double bond O, this double bond O, and this OH. Okay, and here after the decarboxylation, the loss of carbon dioxide takes place to form RNH2. This COO will go as a C double bond O double bond O, that is CO2. This hydrogen will now shift to this nitrogen and forms RNH2, that is primary amine. Okay, this is the reaction mechanism for Hofmann bromamide degradation reaction or Hofmann rearrangement. Okay, the next reaction what we are going to discuss is Gabriel Thalamide reaction. The next reaction we are discussing here is a Gabriel Thalamide reaction. See, the reaction of Thalamide with alcoholic potassium hydroxide. The reaction of Thalamide with alcoholic potassium hydroxide gives Thalamide salt, which on treating with alkyl halide, and followed by the alkaline hydrolysis, gives primary amines. This reaction is called as Gabriel Thalamide reaction. Okay, this Gabriel Thalamide reaction is the reaction of Thalamide with alcoholic potassium hydroxide, which first it will give Thalamide salt, and this Thalamide salt on treating with alkyl halide followed by the alkaline hydrolysis, it gives primary amine. See, we can write the general reaction for this one. This is what? Thalamide. Okay, when this Thalamide is treated with alcoholic KOH, the first one is what? Alcoholic KOH. It will give Thalamide salt. Okay, and that Thalamide salt which I am treating with alkyl halide. The second one reactant what we are adding here is alkyl halide followed by alkaline hydrolysis, that is by the addition of aqueous sodium hydroxide we will get primary amines, and here we are getting C double bond O, O minus Na plus, O minus Na plus. This is what? Sodium phthalate as a byproduct. Okay, this is called Gabriel Thalamide reaction. And for example, we can take this is Thalamide. When it is treated with alcoholic solution of potassium hydroxide along with C2H5I, that is ethyl iodide, C2H5I ethyl iodide, and on adding aqueous sodium hydroxide, we will get C2H5NH2, ethylamine, primary amine, and along with the formation of minus Na plus, O minus Na plus. This is what? Sodium phthalate. And another example we can take here, the reaction of Thalamide with alcoholic KOH along with methyl bromide as alkyl halide, and on adding sodium hydroxide, aqueous sodium hydroxide, we will get methylamine CS3 NH2, methylamine. Okay, and another byproduct is C double bond O minus Na plus, O minus Na plus. This is sodium phthalate. Okay, this is Gabriel Thalamide reaction. When Thalamide is treated with an alcoholic KOH, first it will give Thalamide salt, and that Thalamide salt, which on treating with alkyl halide and also by the addition of alkaline hydrolysis or by the reaction with aqueous sodium hydroxide, we will get a primary amine. And these are the some examples. Okay, then coming to the reaction mechanism. Reaction mechanism, it involves the following steps. The reaction mechanism of Gabriel Thalamide reaction involves the following steps. Step number 1 is what? Base abstracts a proton. Base abstracts a proton from Thalamide and gives potassium salt of Thalamide. First, base will abstract proton from Thalamide, C double bond O, C double bond O. Okay. Here the OH minus from the base, that is KOH, will now abstract this hydrogen, and these bonded pairs of electrons will now move towards nitrogen, and it results in the formation of C double bond O, C double bond O, N, N. Here this is minus, along with this OH we can write K plus, minus K plus. Okay, this is called what? Potassium salt of Thalamide. This is first step of the mechanism. And in second step, this is salt of the Thalamide. This is salt of the Thalamide on reaction with alkyl halide. On reaction with alkyl halide gives N-alkyl Thalamide. N-alkyl Thalamide. See this salt. Will now react with the alkyl halide RX, and this negatively charged nitrogen will now attack on this alkyl group, and this halide will go with a bonded pair of electron X minus on heating, and here we will get a C double bond O, C double bond O, N R. This is what? N-alkyl thalamide, N-alkyl thalamide. And the last step of this mechanism involves this N-alkyl thalamide on alkaline hydrolysis. On alkaline hydrolysis undergoes cleavage and on proton transfer gives primary amine. Okay, the last step involves what? This N-alkyl thalamide on alkaline hydrolysis, that is on the addition of aqueous sodium hydroxide, it will undergo cleavage. Okay, and followed by the proton transfer, it gives primary amine. See, this is that N-alkyl thalamide, and on addition of aqueous sodium hydroxide, which is there as Na plus and OH minus, this OH minus will now attack on this carbon. This OH minus will now attack on this carbon, and this bond will break, and the bonded electrons will now move towards nitrogen. Okay, and here we can write C double bond O, C double bond O, OH. OH will add here, and here we are getting N minus R. Okay, and the next step is what? Proton transfer, that is H plus ion transfer. This proton will be now abstracted by this negatively charged nitrogen, and these bonded pairs of electrons will now move towards oxygen. After proton transfer, we will have C double bond O, NHR. Okay, and here we are having C double bond O, O minus, and along with this one Na plus is also there in a medium, Na plus. Okay, and now the next step involves what? This another C double bond O is there, na? And NH bond is there, na? Here also another molecule of sodium hydroxide will react with this one. This OH minus will now attack on this carbon, and this bond will break. Okay, and here we will get C double bond O, OH. After the addition of OH to this carbon, we will get C double bond O, OH, and here COO minus, this I am writing like this, COO minus Na plus. Okay, and the next step involves what? Proton transfer, that is H plus transfer. See here in the reaction medium, this NHR is going out, na? Here we can write NHR minus. It is going with a bonded pair of electron, that is bonded pair of electron means negative charge, and this negatively charged nitrogen is now abstracting this proton, and these bonded pairs of electrons are moving towards this oxygen, and therefore here we will get C double bond O, O minus, Na plus, C double bond O, O minus, Na plus, plus this NH to RNH to, this is primary amine. Okay, this is a sodium thalate. This is the reaction mechanism for Gabriel thalamide reaction.